We've looked at the components of the atom, and we've seen how the atom is made up of three parts: the electron, the proton, and the neutron. We've seen that you cannot change the number of protons in any given atom without changing the identity of that element. But we've seen that we can change the number of electrons to result in cations or anions, so we can gain or lose electrons. And as a matter of fact, that's what results in chemical reactivity. That's where we end up having chemical reactions when we change the number of electrons. Now, the third component, the neutron, can also change in a given element. So you can have one atom of neon that has 10 protons and 11 neutrons, or you can have another atom of neon that has 10 protons and maybe 12 neutrons. So the neutrons can vary, and when we have the same number of protons but different number of neutrons, that is called an isotope. And an isotope is symbolized like so, where X is your chemical symbol. Your Z here is your atomic number that we've talked about, and A here is your mass number. And we know that the Z is easily found because it's your atomic number that we look up off the periodic table. The A is the mass number, is the number of protons plus the number of neutrons. So Z again is your number of protons and plus number of neutrons. And these are found in the nucleus. So A is the total number of protons and neutrons in the nucleus of an atom. So let's do an example. What is the atomic number Z, mass number A, and the symbols of the carbon isotope with 7 neutrons? So we know we have carbon. We can easily look up the atomic number Z in our periodic table, and we find that 6. Now, to figure out the mass number A, we know that we need the number of protons plus the number of neutrons. And we already know the number of protons is 6, and we're given the number of neutrons. So our atomic number becomes 13. So we have 13 protons and neutrons inside the nucleus of a carbon isotope. And we write the symbol like so, with the Z on the bottom and the A on the top. And if you notice that the 7 or the 6 here for the carbon atom is redundant. When you say carbon and you say 6, it's really referring to the same thing, because we know we cannot change the atomic number without changing the identity. So you can also represent isotopes like so, in which you give the chemical symbol and you just give the mass number. So both of these would be correct. So go ahead and give this a try. What are the atomic mass, or the atomic number, mass number, and symbols for the chlorine isotope with 18 neutrons? So we know that it's chlorine. So we know, we look up its Z value, or its atomic number, from the periodic table, and we find it's 17, which is our number of protons. And our mass number is our number of protons plus our number of neutrons. So our number of protons is 17 plus our number of neutrons is 18. So our mass number is 35. Okay, so we put our mass number here on the top, and we put our Z number, or number of protons, on the bottom. And so we get this symbol, but we want symbols. So let's do the other way of writing this. because writing 17 protons and writing the symbol for chlorine is redundant, because we know we can identify chlorine either by its symbol or by its proton number. So we don't have to do that when we can represent it as just chlorine 35 with its mass number only. Now sometimes you're just given the isotope symbol and you need to figure out the number of protons and neutrons, for example, in the chromium isotope, chromium 52. So we go ahead and we look up chromium in the periodic table, and we find that it has a Z number or atomic number of 24. So we know it has 24 protons. Okay, now in this case, we are not given the number of neutrons, we're given the mass number. But remember, your mass number is your number of protons plus your number of neutrons. And we have the number of protons, and we have our mass number, so we just have to solve for the number of neutrons. So your number of neutrons becomes your A minus your number of protons. Is just rearranging the equation algebraically. So our A number, or our mass number, is 52 minus our number of protons of 24, which is 28. And the way I like to think of this is top minus bottom gives you the number of neutrons. So you see, when we have this, we have our mass number here, and we have our atomic number down here. So it's just 52 minus 24. Top minus bottom gives us the number of neutrons. That's just a quick way to remember it. Okay, now go ahead and give this a try. How many protons or neutrons are in the potassium 39 isotope? So again, we see we have potassium 39. We go ahead and we look up the atomic number for potassium, and we find that it's 19. And so our number of protons is our Z number of 19. And our number of neutrons is just the difference between these two. So 39 minus 19. Remember, that's our shortcut way of figuring that out. But at the end of the day, it's our mass number minus our atomic number. It gives us the number of neutrons.